May have some idea of what we mean by subset. Here's the definition. A is a subset of B if every element of A is also an element of B. A is a subset of B if every element of A is also an element of B. The idea meaning, yeah, this is A is a part of B. Another way you could put it. Everything in here is also an element here. So a real good example here. Yeah, if I had A is little a, little b, little e. B is A through E. A is a subset of B there, isn't it? Every element of A is an element of B. Right? That's what I mean by subset. Now there is a special symbol for the subset, and it looks like this. It's kind of a U or an arch turned over on its side, and then a line below it. That's the subset symbol, and this does mean this. That symbol there means is a subset of. It goes that way. Because, would this be true? What does that say? B is a subset of A. Is that true? Nope. B is not a subset of A. Every element of B is not an element of A, is it? Because you got C and D that aren't. So yeah, it goes that way. It means is a subset of. So this one is a subset of that one. So B is not a subset of A. Okay, now, if I throw in set C here, and set C is A and E, what can you say about that one? Subset-wise. C is a subset of B, isn't it? Is there anything else we can say? C is a subset of A, yeah. C is also a subset of A. So subsets can be subsets of more than one set. Subsets have subsets of themselves, but anyway, different things. Now, let's try this one. How about, pick one, A subset of A. Throw that one out there for you. Is that one true, or does it need a slash? A is a subset of itself, basically. Well, let's think about the definition. Definition says A is a subset of B if every element of the... Let's read it this. The first one is a subset of the second one if every element of the first one is also an element of the second one. Is every element of this one, the first one, an element of the second one? Yep. Yes, it is. This is true. A is a subset of itself. So guess what? B, subset of B. C, subset of C. Every set is a subset of itself. So we get to thinking, subset, you're talking about a smaller set, but not necessarily. It could be the same size. A is a subset of itself. B is a subset of itself. Every set is a subset of itself. Because it falls into the definition, right? Every element here is an element there, yeah. So that's going to be true of every set. B is a subset of C, B is a subset of B, C is a subset of C, so on and so forth. Okay? With me? Okay. What about this one? What's that saying? The empty set is a subset of A. Slash or no slash. Is that one true? Is the empty set a subset of A? Well, yeah, this one's probably one of the trickier ones. And it turns out it's true. The empty set is a subset of A. Now you might be thinking, how come? Well, in a moment I'll go through a little example and maybe explain a little more, but right now it's just kind of by default, because when I say, let's say I put a set D up here. Set D is, let's make it E, F, and G. Well, sure, D is smaller than B, but is D a subset of B? No. D is not a subset of B. Why not? Because it has an element that's not in B, right? F, and it has two elements, matter of fact. But it has an element that knocks it out from being a subset, right? You see what I'm saying? Is there anything that knocks this one out from being a subset? What element here is not an element over there? There isn't one. It's kind of by default, one way to think of it right now anyway. Yeah, there's nothing here that restricts that from saying this, there's an element here that's not over here. Because there's not any elements here that are, well, there's not any elements over here, but you get the picture of what I'm trying to say. Yeah, the empty set is a subset of A. Guess what? The empty set is a subset of B. It's a subset of, the empty set is a subset of any set. Okay? So keep these two things in mind. They're kind of specialty subsets there, but nonetheless they are, okay? The empty set, and I'll kind of explain a little more here in just a moment. But note that. Okay, the other, there is another term here, and I'm going to have to erase these so I can write it. Very much related, but it's called a proper subset. This is a subset, just regular subset. There is a thing called proper subset. Let's talk about it. And it also goes, A is a proper subset, kind of starts the same way. A is a proper subset of B if A is a subset of B, but there's an extra restriction, and A does not equal B. They're not the same. In other words, to be a proper subset, yeah, you have to have a subset, but you can't have equal sets there. It's a little bit of a restriction. So I need to talk about equality more in just a second. Don't let me forget. Okay. So a while ago we had, and here's the symbol. Basically the same symbol, except there's one part missing, right? Why is this different than the one we just talked about? There's no line, yeah. The line's missing. So without the line there, that's the proper subset. So if A is a proper subset of B, this is what you write. What does it mean? Well, a while ago we had A, what do we have? A was ABE. B was A, B, C, D, and E. That was a subset. But now can we say it's a proper subset? Because a lot of subsets will be proper subsets. You get proper subsets as well. But can we say that in this case? Is A proper subset of B? Yes. That's true. A is a proper subset of B. Because, how do I know that? A is a subset, and the only other restriction is A is not equal to B. Is A equal to B? No. A is not equal to B, so it is a proper subset. So a proper subset just means it's not equal to, which basically boils down to what about that? Is that a proper subset? Is B a proper subset of B? No. Why not? Because it's equal. To be a proper subset, this has to not equal that. Well, obviously this equals that. So it's not a proper subset. So here's what it boils down to. To be the specialized proper subset that we're talking about, the set has to be smaller. For A to be a proper subset of B, yeah, A can't equal B. So that just means A is a smaller set than B. It's just going to be a smaller set. That's another way you could put it. It's a subset, and it's a smaller set than B. So the only, really the only ones you run into a problem with on the proper subsets is the sets themselves. B is not a subset of B, proper subset of B. A is not a proper subset of A, so forth and so on. As long as it's smaller, it's a proper subset. As long as it's a subset and it's smaller, it's a proper subset. Okay? So what about the old empty set? The empty set is a proper subset of B. True? Well, like we said, to be a proper subset, it has to be a subset, which we know it's a subset, and it has to be smaller. Is this smaller than B? Yep. Yep. So the empty set's a proper subset of B. Okay? One other thing, because when we get going, I think in the homework they have some true and false on these and some different things, but keeping the two, let me talk about the two symbols here. Which one is this? Subset or proper subset? That's subset, that's proper subset. Of course, I've got some of it up here already, but kind of keep it straight. It seems to work pretty good, but if you look at this, if you just do a little bit of a connection there, that looks more like an S for subset. And if you look at this, kind of think of that line there, that's more like a backwards P for proper subset. So that's kind of a stretch there, but it seems to work. I've told my classes that a couple of times now. It seems to help it keep it straight because a lot of people were not keeping it straight before, but more often they are now since I mentioned that. So that's one way to keep it straight. The other thing is to note here the connection between this and then this. What is this? Less than or equal to, strictly less than. There's a connection there, and I'm sure it's not by coincidence that they chose this, because less than or equal to, right, means less than or equal to. Isn't that kind of what this means? Less than or equal to. A is a subset of B. Subset basically means it's less than, but it could be equal to, right? For subset. Now, for proper subset, it has to be less than. Has to be less than. Just like that has to be less than. It can't be equal to, you see. So there is a connection there. But anyway, okay? I'll come back to that because I wanted to, well, yeah, let me go ahead and talk about, yeah, it makes more sense to talk about now. All right, let's talk about the number of subsets for just a moment. the number of subsets a set has. Turns out there's some interesting little patterns here and a couple of points, too, that we can make. What I like to do on this is approach it this way. Let's say I had the set, let's just start with MK. And I want to list all subsets. Okay? And here's the way, let's put this another way here. Let's say we opened up a sandwich shop. Okay? And say we were serving turkey sandwiches. Okay? On hand, for these turkey sandwiches, I have mustard and ketchup. I want to think about all the different possible sandwiches here I could make out of those two condiments. Well, I could have what? Mustard only? Ketchup only? What else could I have? Mustard and ketchup? But what else? Nothing at all. Neither one of those, which is, in our terms, the empty set. Okay? So you see there, the empty set is one of the subsets of this, because that's what we're talking about. All these different possibilities are all the subsets. So yeah, I've got to do the mustard only, I've got to do the ketchup only, I've got to do both of them, but then I've also got to include neither one of them, the empty set, using neither one of those, you see. So the empty set is a subset of any set you want to come up with. Okay? So I've got 4 subsets. You think of any others? Okay. All right. We did pretty well. Opened up with mustard and ketchup. We were only able to afford those up front. We did pretty well, so we were able to add pickles. Okay. Now, how many ways sandwiches can we make there? What are the subsets of it? Well, it could have the mustard only now still. It could have the ketchup. It could have the pickles. What else could I have? I could do the 2, mustard, ketchup. 2 of them at a time, right? Mustard, pickles, or ketchup and pickles. What else? Well, I could do the deluxe, in this case, which would be all 3, mustard, ketchup, and pickles. The set, all 3 at once. Any others? Or the empty set, yeah. No, plain turkey sandwich, okay. You could still have that. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. Had 4 here, had 8 there. Okay, well, we've had some rough economic times. Well, rough economic times hits our sandwich shop. We get to where we only have mustard. Now what can we do for subsets? Well, we can have mustard only, or we can have nothing. Okay, you only have 2. All right, 2 subsets there. I do that because here's what I want to look at. One thing, I could expand this to force. Let's say I did mustard, ketchup, pickles, and onion. Had 4 possibilities. Well, how many subsets would that have, you think? Well, this one we had 4. We added an element, we had 8. What seems to be happening there? Well, let's look at it from here. If I only have 1 element, I have 2 subsets. If I have 2 elements, I have 4. If I have 3 elements, I have 8. What seems to be happening there? Aren't they doubling every time? So if I had a 4th element, mustard, ketchup, pickles, and onions, probably going to be how many? 16. Yeah, it doubles. Every time you add an element, you double the number of subsets you have for that set. So if I went to 5 elements, it would double up to 32. So there's a doubling process. But there's even a stronger thing we need to mention here. If you notice here, these subset numbers, I got 2, 4, 8, and it does go to 16. That would take a while to list all those, but there would be 16 of them. If you already know what it is, don't say so just yet. Okay? You notice something about these numbers. I mean, they're all even, obviously, but 6 is even and it's not there. 10 is even and it's not there. There's something else special about these subset numbers: 2, 4, 8, 16. Anybody note what those are? What kind of numbers those are? Think powers. What are they? They're powers of what number? Powers of 2, yeah. 4 is 2 squared. 8 is 2 cubed. 2 times 2 times 2. 16 is 2 to the 4th, and even 2 is 2 to the 1st. Yeah. The number of subsets is always a power of 2. Always a power of 2. So I asked you how many subsets. You know it's a power of 2. But there's another little connection here. Notice this set has 1 element, and there's 2 to the 1 subsets. This one has 2 elements, and there's 2 to the 2nd subsets. This one has 3 elements, and there's 2 to the 3rd subsets. This one has 4 elements, and there's 2 to the 4th subset. So if I had 10 elements, how many subsets is that going to have? 2 to the 10th power. Yes. The power of 2 for your number of subsets is always the number of elements there are. So here's the way we can write. The number of subsets a set has for any particular set, for a set, is a power of 2. It's 2 to a power. Let's write it 2 to the n power, where n, the power, is the number of elements the set has. Is it 2 because why is it the 2? No. It's just the way the numbers work. I don't know how really to describe it. It's just the way the different permutations all work out. That's why is it not 3 or that's a good question, and probably a little bit more involved than we can get right now. But there's a lot of things that do this doubling. The doubling reason. Like I said, it kind of has to do with the permutations of it all. But it's always a power of 2. 2 to a power, and it turns out the power is the number of elements the set has. So if I had 10 elements, it would be 2 to the 10th. So let's do one here. Oh, let me leave that up there. Try to anyway. Okay, so if I had this set, A, B, C, D, E, F, G, H, I, J. How many subsets? See if we can figure that out. How many subsets does A, B, C, D, E, F, G, H, I, J have? Is it 2 to the 10th? It is 2 to the 10th, isn't it? Why is it 2 to the 10th? Well, it's 2 to the... We know it's a power of 2. And why is it the 10th power of 2? Because there's 10 of them right here. Yeah, 10 elements right there. So it's 2 to the 10th. Now, be careful when you punch that in on your calculator. It's not 20. 2 to the 10th is not 20. It's not 10 squared, which is 100. It's not 100. It's 2 to the 10th power. Most calculators, it's either this button, little arrow tip looking button, or some calculators have X to the Y button. Just depends on type of calculator you have, but one of those buttons, use that, because 2 to the 10th power, and if all else fails, do 2 times 10 times. What do you get? Should get. Anybody got it? 1,024. There you go. There's 1,024 of those subsets. If we wrote them all out, take a while. Because it's doubling, it doesn't take very long to double up to a large number. Okay, I left all these up here to then, let's tack on one other little piece. What about the number of proper subsets? Well, going back through our listing method here, if I list all the proper subsets, is that a proper subset? Remembering what's the deal on proper subset? To be a proper subset, it has to be subset, but smaller. So is this a proper subset? Yeah, it's a subset and it's smaller. Is this a proper subset? Yes, because it's smaller. Is this a proper subset? No, because it's not smaller. Is this a proper subset? Yes. So there's 3 proper subsets in this case. Okay? Same thing down here. If I was going to do the proper subsets on here, is this one? Yes. This one? Yes. All these are because they're smaller. MKP is smaller than MKP. This one isn't, though, right? Because it's not smaller. This is smaller. Okay, so there's 1, 2, 3, 4, 5, 6, 7 proper subsets on this one. 8 subsets, but 7 proper subsets. And then up here, well, this one's not smaller, so there's only 1 proper subset. What's going on here? Well, yes. Proper subsets, really all it comes down to is we lose 1 set, right? This one's a subset, but it's not a proper subset. So there's 8 subsets here, but there's only 7 proper subsets. There's 4 subsets, but there's only 3. So what's the story? The number of proper subsets is always what to the number of subsets? It's 1 less. The number of proper subsets is always 1 less than the number of subsets. That's the rule. The number of proper subsets is always 1 less than the number of subsets. Whereas she put it there, if we wanted to write it in a little formula here, the number of proper subsets well, the number of subsets is 2 to the n, so the number of proper subsets would be 2 to the n minus 1. You want to use a formula. Right? Make sense? All right, so let's do this. Okay? All right, so let's say I have all right, so I got 3, 4, 8, 11, 15, 19, just random numbers here. 21. How many proper subsets does that have? That set. Well, let's start with the number of subsets. The number of subsets would be 2 to what? Well, we got 1, 2, 3, 4, 5, 6, 7. So the number of subsets would be 2 to the 7th, which is 128. So how many proper subsets? Well, it would be 128 minus 1, wouldn't it? 127. Okay? Make sense? All right. Let me go back to equality here real quick. I meant to, last thing before, give you a little break here. Is this okay, though? Everybody got that one? 127?